Alright, problem 4. Let's multiply binomial radical expressions. Binomial radical expressions, have you done this before? Yes, you have. So this is the part where any math teacher that's worth their salt will go back and review a very similar situation in which you did multiply binomials together. Let me set up the scenario for us, shall we? How about this situation right here? How many times have you had a math teacher ask you to do this? X plus 3 times x minus 7. And have you multiply those together? Some of you did distributive property, distributive property, distributive property, distributive property to get you those four terms, right? Your x squared, your 7x, your positive 3x, your negative 21, and then, oh look, like terms, combine those together, and you would have arrived at x squared. That would be minus 4x minus 21. Sometimes you did it this way, right? Other times you ran across teachers that told you to do it this way, where you could say, well, I don't think they told you to do it this way, they just offered this to you, okay? There you go. And then we filled those in and said, hey, that's x squared, there's 3x, there's minus 7x, there's negative 21, and say, oh look, there's the like terms right there. We combine those together, and because I'm mega lazy, we'd get that exact same answer right there, right? Right. So there are multiple different ways we can multiply binomial expressions, or with linear factors together, okay? This, ladies and gentlemen, over here is no different. Absolutely no different. It looks messy. It looks messy because the way that they did this here in the textbook was this stuff over here on this side. Okay? And the only other reason why it gets messy is because we're dealing with some square roots. Now I'm going to go over here in our little review board here for a second. Let me put this towards you a little bit. We know this, right? If I give you, let's clear this out. If I give you the square root of 7 times the square root of 3, properties allow us to say, yup, you are equal to the square root of 21. Okay? Nothing wrong with that. Suppose, though, I gave you the square root of 7 times the square root of 7. Wouldn't that give you the square root of 49? And then, wait a second, unlike this one where we can't do anything with and it's already simplified, this guy right here would actually simplify to 7. So what's the lesson learned here is that when we have the same square root, or in other words, if we were taking the square root of a quantity and squaring it, the answer is actually the number that, what was that vocab word again? The radicand? Yeah, the answer is the radicand, right? For this reason right here. Interesting. Let's store that away, and we might need it a little bit later on when we look at these problems here. Okay? So if you find this little mumbo jumbo here a little bit confusing, sure. What if we set it up this way? How about I put this on the side and put that little box method there? A lot of you loved this box method. Okay? I will spare you from any more math in the box jokes. Although, didn't I just do one? Sorry. Just doing something to pass the time as I write down all this stuff. And then let's double check, make sure I've got all of the proper, oh, it's all positives, that's good. All right, so 4 and then 2 square roots of 2, 5 and then 4 square roots of 2. So the first blank right here, isn't that the combo multiplication of 5 times 4, which would give us 20. Now, here's where you got to be careful. It is okay to multiply the integer times the integer. Do not do distributive property when it comes to this type of multiplication here. Okay, the only thing that you're going to do is 5 times 2, and literally that's it. So we'll have 10, and then we still have a square root of 2. Okay, and then down below, wouldn't that be 4 times 4, the same way reason why we're doing 5 times 2? So wouldn't that be 16 times the square root of 2? Now this is where it gets a little bit interesting. Okay, the 2 times the 4. The 2 times the 4, wouldn't that give us 8? Let me write the 8 down. And now I'm going to do some highlighting here. We're doing the square root of 2 times the square root of 2. Now if you were mega lazy like me, I would know that if I'm doing a square root of 2 times a square root of 2, I would know exactly what that answer would be. It would be 2. But if we really want to be precise here and show all of our work here, wouldn't this really technically be, and I'll use green here, it would technically be the square root of 4, right? But we know that's eventually going to turn into a 2. All right, so let's clean all this mess up here for a little bit here. So the first number we got there, it's the 20, right? And then, oh look, I'm running out of highlighter colors here. Let's go red. 10 square roots of 2 and 16 square roots of 2. Aren't those like radicals, like this whole lesson's been about? Yes, it has been. So wouldn't that give me 26 square roots of 2? Sure would. And then let's just pick on this last guy right here in this bottom right hand corner. We'd have plus 8. Now last time I checked, when you put a number next to a square root, that means multiplication, right? So I'm going to put a times dot right there. And then the square root of 4. Isn't that 2? Okay, so then allow me to cross this off here. 8 times 2, last time I checked, that's 16. So really, aren't we just doing this? We have that 26 square roots of 2, which, as you can see, is right there, and it's positive. And then we also have 20 plus 16, which is 36. Awesome. Okay, so your turn. I don't care how you get there, just get there if you can, whether you're going to be doing lots of arcs and arcs and arcs and arcs. I missed that third one there. Let me clean that up. Okay, if you want to do it that way, or if you want to set up that box method, give this one a shot. Okay, pause. Alright, I took the liberty of already writing in those guys here for us, so let's just multiply, right? So if you did this right, you should have had a 6 right here. We had a lot of you struggling with this back in chapter 5, and the struggle that was happening when you guys were doing this is it was that real tricky juggling act of when you should be multiplying numbers together versus when you should be adding. Common mistake here, a lot of students love to put 5 in there. And some of you are nodding your heads right now. It's like, yep, that was me, that was me, that was me. Okay, remember, when you are filling in the boxes, it's all about that multiplication. Okay, so multiply, 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 multiply. If you do this second upper right one correctly, you should have 4, right? 2 times 2 is 4. And then you have a square root of 5. Don't touch that. Okay, it's Dale's drum set. Don't touch it. And now 4 square roots of 5 times 3, that would be 12 square roots of 5, right? And then over here, if you really want to shortcut this little operation right here, see how I had 8 times the square root of 4? Why don't we just do this? Okay, let's do the 4 times the 2. Let's get the 8, and then I'll keep in green here. The square root of 5 times the square root of 5. Wouldn't that just be a 5? Okay, in other words, in this box, Mr. Cook's going to write a 40. Okay, now when you look for your like terms, see how you have your like terms here? You also have like terms here and here as well. Okay, so now when we simplify our answer and write our final result, let's write the real parts first. You always write the, well, not the real part, the integer answers. Always write your integer answer first. So 6 is an integer and 40 is your integer. So that combined result would be 46. And now you can write your irrational part second. So a positive 12 radical 5 and then a positive 4 radical 5. That would combine to give you 16 of those square roots of 5. Capiche? Yeah. Okay. That would be the product. Looking good. Looking good. One more video left, and this is the next one that we're going to look at. The difference between these ones, well, I'll explain in the next video. Okay?